Standard 10th Mathematics Part 2 Chapter Trigonometry. In video number 8, Application Oriented Practice Set Problems.
Now children, the application part. Over here, let's see and observe the problem on the board. If sin theta is 7 upon 25, find the values of cos theta and tan theta. In the earlier session, children, we used the trigonometrical identities, one method to find out the values of the unknown. But over there itself, I have told you that there is another method where we can again find the values of the unknown. Which is that method? Let's understand. That is by using the triangle, right angle triangle, and applying the Pythagoras theorem. So first, to begin with, the right angle triangle A, B, C. Let's not forget to mark the angle which is measuring 90 degrees. Now over here, sin theta is given as 7 upon 25. Let's mark any one acute angle as theta. So over here, sin theta. What is sin theta, children? Sin theta is opposite side upon hypotenuse. It's a ratio, children. That is opposite side upon hypotenuse. Is it the actual measurement given? No. So definitely we cannot write it as AB is equal to 7 and AC is equal to 25. It is a ratio. How do we change a ratio into a value, into a measurement or length of a side? By assigning variable. That means if the opposite side, the ratio is given upon hypotenuse as 7 upon 25, actually the values of AB and AC will be 7A and the hypotenuse will be 25A. Ratio is converted into actual lengths by assigning variables to it. So over here, AB, length of AB will be 7A and length of AC is equal to 25A. To find out the value of cos theta and tan theta, we have to find out the value of the third length, that is BC in right angle triangle ABC. Only then we can find out any value of any unknown term. So to begin with, children, in this right angle triangle, can we use Pythagoras theorem to find out the value of the length of the third side? Definitely. What is Pythagoras theorem? AB square plus BC square is equal to AC square. What have we applied over here? Pythagoras theorem. Is AB given to us? Definitely. It is 7A. So 7A the whole square plus BC is unknown. Write it as it is. How much is AC? 25A the whole square. Let's solve it. 7A the whole square will be 49A square plus BC square, which is equal to 25 into 25 gives us 625. A into A is A square. We have to find out the value of BC. So let's transfer 49A square to the other side. So we get BC square is equal to 625 A square minus 49 A square. Thus, BC square, to move on with our calculations, you can take out A square common into bracket 625 minus 49. BC square, which is equal to A square, into 625 minus 49 is 576, right? So therefore BC square is equal to a square into 576. When you take the product, gives you 576 a square. Taking the square root on both the sides, because ultimately we have to find out only the value of BC. So what do we do? Square root of BC square is equal to square root of 576 a square. Square root of BC square is only BC, which is equal to square root of 576 is 24. Square root of a square is a. We do not consider the negative square root value because we are finding out the length. Measurement and length of any side can never be negative. So we are only using the positive value and discarding the negative one. So finally children, we got the value of BC, that is 24a. So let's write it down and see what are the values of the unknown. BC is equal to 24a. Now we know the lengths of all the three sides. Definitely children, we can find out the values of any unknown terms asked to you. But over here they have asked cos theta. What is cos of theta? Adjacent side upon hypotenuse. A and A gets cancelled. That is 24 upon 25. The other unknown which is asked is tan theta. Tan theta is equal to opposite side upon adjacent side. 7a upon 24a. A gets reduced, so we are left with 7 upon 24. So we know sin theta, we know cos theta, we know tan theta. Children, if they ask you the multiplicative inverse values, what are they? Definitely children, it is so easy. If sin theta is 7 upon 25, cosec theta will be 25 upon 7. If cos theta is 24 upon 25, its multiplicative inverse is sec theta. What will sec theta be? 25 upon 24. If tan theta is equal to 7 upon 24, what is the value of its inverse? Inverse is cot theta. What would cot theta be? 24 upon 7. So children, this was the second method where we applied Pythagoras theorem to get the value of the unknown trigonometric functions when they give you the value of any one trigonometric function. Now, moving on in trigonometry with practice set problems. Let's see the problem on the board. If tan of theta is equal to 1, then find the values of sin theta plus cos theta upon sec theta plus cosec theta. Now, when is it easier for us to find the value of such a big problem given to us? Only if we know the value of the angle over here, that is theta. For this, let's look into what we can make use of given in the problem. What is given in the problem? Tan theta is equal to 1. According to the trigonometrical values that we know is tan of 45 degrees is equal to 1. If tan 45 is equal to 1, in other words, we know that theta is equal to 45 degrees. So at this step, children, we were able to find out the value of theta. So it goes very easy for us to calculate the value of the given expression. Let's see how we move forward. Let's write down sin theta plus cos theta upon sec theta plus cosec theta. For this, children, we have to recall the value of sin 45 as theta is equal to 45, cos 45, sec 45 and cosec 45. We know that sin of 45 degrees is equal to 1 upon root 2. Next, we require cos theta, that is cos of 45 degrees, which is again 1 upon root 2. The remaining two values, sec 45 is root 2 and cosec 45 is again root 2. So we know the values of each and every term in the given expression. So we will have to substitute and then move on with our calculations. So let's substitute. Over here we have sine 45 degrees plus cos 45 degrees upon sec 45 degrees plus cosec 45 degrees. Let's substitute. Sine 45 is 1 upon root 2. So 1 upon root 2 plus, we are just concentrating on the numerator, plus again cos 45 is 1 upon root 2 divided by sec 45 is just root 2 plus cosec 45 is again square root of 2, root 2. To move on with our calculations, we have to solve the numerator as well as the denominator. Now looking at the numerator part, and this is the denominator. In the numerator, if we concentrate, we know that in both the denominators in the numerator term, it is the same. So you can put it under a common term, that is root 2, and in the numerator you will have 1 plus 1 divided by root 2 plus root 2, that is 1 root 2 plus 1 root 2. They are like terms, so definitely we can add them. That gives us 2 root 2. To move on with the calculations, 1 plus 1 is equal to 2. This, children, do not forget, is your numerator and this is your denominator. So 1 plus 1 gives us 2 upon root 2 divided by 2 root 2. Let's move on further. The numerator fraction will be written as it is. So 2 upon root 2. Division changes to multiplication, and when division changes to multiplication, whichever number you have in the denominator, we write its reciprocal. So what is in the denominator? 2 root 2. In other words, it is 2 root 2 upon 1. What will the reciprocal of this number be? It will be 1 upon 2 root 2. Let's see if we can reduce. 2 and 2 gets cancelled. So we are left with, in the numerator, 1 into 1 gives us 1 upon root 2 into root 2 is only 2. So finally, children, sine theta plus cos theta upon sec theta plus cosec theta is equal to 1 upon 2, that is half. So given to you any trigonometrical function, its value, and we are supposed to find the value of the expression. First, it is very important for us to find out the value of theta by understanding the value of the ratio given to us, the value of the trigonometric function given to us. After getting the value of the angle, substitute the value into the individual terms to finally get the value of the given expression.